Welcome to Woodland's Maths videos. We're going to do quadratic graphs today. Parabolas. Causes a lot of difficulty in the Nat 5 course, so let's try and break this down a wee bit to help your understanding. If we plot the graph here, y equals x squared plus 6x minus 16, I've just popped it into one of the graphing packages. Desmos is very, very good. That's what you get when you plot it on Desmos. And we just click on the values and the points where it crosses the axes and also the turning point. So I've just sketched this graph for you to have a look at. And from this, we get a root at -8 and a root at 2. Roots are where it crosses the x-axis. I've got a y-intercept at 0, -16. That's the end number here. And I've got a turning point of -3 and -25. And you might think, how on earth do you get these points? Well, we're going to show you. But to do that, I'm just going to give you a few wee examples here of where you get the roots from. Okay, so where does the graph cross the x-axis? That's what we're trying to find for the roots. Well, I've just given you an already factorized quadratic. And to get the roots from the brackets here, you just take it out and change the sign. So the roots for this factorized quadratic are -6 and -3. That's where it crosses the x-axis. I've done the same thing here with an x -7 and an x plus 5. We get 7 and -5 as the roots. That's where it's crossing the x-axis. What happens when it's a wee bit of more complicated factorising? Well, I've taken the factorising issue out here. I'm not addressing factorising just now. 2x plus 1 and x -8 comes from the quadratic. That would be a content. That gives us 2x plus 1 is 0. So 2x is -1, giving us x is -1/2. And coming from the x -8, I get a root of x equals 8. So this quadratic is going to cut the x-axis at -1/2 and at 8. And when we just have the x in front of a bracket, that automatically gives us an x equals 0 and an x equals 1. So factorising and solving gives us the roots of the equation. The roots are where it crosses the x-axis. Okay? If I go further down, I'm going to consider the graph above again. And the graph above is x squared plus 16x minus 16. If I factorise that, and I've just popped in wee links, some of you may know what that means, but I factorised that and I'm getting roots of -8 and 2. And that's the same as the graph above. Another example here would be if I've got x squared plus 5x equals 0, let's take out a common factor, make it equal to 0, and that gives us 0 and -5, and that's where the roots would be. Okay, so again, that's some practice. Some of you will know what we're talking about. Now, if I come over here, there we go, nice technical issue there. I'm now going to consider the turning point from the previous graph. Now, your turning point will come from completing the square. And it depends how you've been shown how to complete the square. I have got a video of that, and so you might want to look that up. But there is my quadratic equation. If you complete the square, I half it, I square it, and then I see what I need to get back to -16. So I've got -25 on the end of that. And then I refer to this as the change and leave process. I want you to change what's inside the bracket, which gives you -3, and I want you to leave the -25. So if you complete the square and then change what's inside the bracket and leave the end number, that will give you the turning point. All right? So the turning point from the graph is -3 minus 25. The turning point from us completing this square is the same. Final wee example. If I have got x squared minus 4x plus 7 and you're asked to find the turning point, complete the square, and remember, I want you to change what's in the bracket and leave the number on the end. So we change what's in the bracket from -2 to +2, and we leave the value on the end. And we will get a wee sketch looking like that, with the turning point being 2, 3. Again, a wee bit of practice if you know what that refers to. So I hope that helps a wee bit.